In this video, we're going to walk through an example of how to find the acceleration in a system that involves an incline, a pulley, and friction. So let's jump right into this example. This says, in the diagram below, a 10 kilogram mass is placed on a 30-degree incline relative to the horizontal and attached to a 15 kilogram mass with a string. Assume the coefficient of friction is mu equals 0.3. Find the acceleration of the system. So I've gone ahead and sketched out this situation. We have this 30-degree angle incline, and on the incline we're placing a 10 kilogram block, and it's connected with a string and a pulley to a 15 kilogram block that's hanging off the edge here. So in this case, because this mass is larger than this mass, I'm going to make the assumption that the acceleration of this system is going to be in this direction. So the larger mass is probably going to pull the smaller mass in this downward direction. Now, our question is, how do we find that acceleration? So what we need to do is we need to identify the forces acting on both this block and this block. So let's start with this first block right here, this 10 kilogram block. We know that the force of gravity will be acting directly downwards on this block. Now, the force of gravity is simply equal to the mass times the magnitude of gravity. So for this mass, let's call this M1, mass 1. And we'll call this one, let's call this M2. So the force of gravity here is just going to be M1 times G, the magnitude of gravity. Now, instead of working directly with this force of gravity, what we can do is break it up into its components. So we can say there's a perpendicular force, so this force that is perpendicular to the inclined plane, and we can say there's a parallel force, so this force that is parallel to the inclined plane. So instead of working directly with this force of gravity, we're going to work with its two components. Now, what we need to realize is that this angle right here, this is going to be the exact same as this angle. So this is also going to be 30 degrees. Now, if that's not immediately obvious, just consider that right here, we have a right triangle. Because remember, the force of gravity is directly perpendicular to the horizontal. So this is a 90-degree angle. And what we know about a triangle is that the three angles in a triangle must add up to 180 degrees. So if this is 90 and this is 30, 90 plus 30 is 120, this missing angle must be 60. And one other thing we know is that this is a right triangle, because remember we drew this force that is perpendicular to the incline. So if this is 90 degrees and this is 60 degrees, then this missing angle right here, this little tiny angle, must be 30, so that these two add up to 90 degrees. So that's why these two angles are equal to each other. Okay, so after we've established that, we need to determine what is the magnitude of this perpendicular vector and this parallel vector. Well, for this perpendicular vector, it's simply going to be the force of gravity times the cosine of this angle. So that will be m1g times the cosine of 30 degrees. And the magnitude of this force is going to be m1g times the sine of 30 degrees. So instead of working with this force of gravity directly, we're just going to work with these two components. Now, when we have the force of the block pushing down on the incline, Newton's third law says that there's going to be an equal and opposite force pushing back, and that's called the normal force. So that's going to be equal to this magnitude. So that will be m1g times the cosine of 30 degrees. And the last force that's acting on this block is the force of friction. So we're told that the coefficient of friction is 0.3. So to find the force of friction, here's what we need to know. The force of friction, let's call that little f, that's simply equal to the normal force times the coefficient of friction. So we just found the normal force, and we're told that the coefficient of friction is 0.3. So this force of friction is going to be m1g times the cosine of 30 degrees multiplied by 0.3. And remember we said that this system is going to be moving in this direction as the larger mass is pulling the smaller mass up the incline. So the force of friction is going to oppose that movement, and it's going to be pushing in this direction. So little f, our force of friction, is also going to be headed in this direction. So those are all of the forces acting on this block. Now on this block, we also have gravity pulling it down. So the force of gravity is simply going to be the mass of this block times g. So we'll say m2 times g, the magnitude of gravity. So what we can say is that the net forces acting on this entire system, it's going to be, we'll say that this is the positive direction. So we'll say this is the positive direction of acceleration. So this m2g, this would be a positive force. But then we have to subtract the force of friction, and we have to subtract this parallel force, because remember, both of these forces are going in the opposite direction. So we'll say minus, remember the force of friction we just found, so m1g times the cosine of 30 degrees times 0.3. And we have to subtract m1g times the sine of 30 degrees. So m1g sine of 30 degrees. Let's squeeze that in here. Now, according to Newton's second law of motion, the net force is equal to the mass times the acceleration. So we can replace this net force with the total mass in the system, which there's two masses, times the acceleration. So we'll say m1 plus m2 times the acceleration must be equal to this whole quantity right here on this right-hand side. So I'm going to go ahead and rewrite that. Okay, and remember we want to solve for acceleration. So all we have to do is divide both sides by m1 plus m2. So these will cancel out. On the left-hand side, we'll have this whole quantity divided by m1 plus m2. And this whole quantity will be equal to the acceleration. So let's go ahead and write that down here. We'll say A, the acceleration is equal to, we have m2 times g, so m2 is 15, times g, the magnitude of gravity is 9.8, minus m1 times g, so 10 times 9.8, times the cosine of 30 degrees. The cosine of 30 degrees turns out to be about 0.866. And we're multiplying that by 0.3. And then lastly, we're subtracting m1, so 10, times g again is 9.8, times the sine of 30 degrees, which is 1/2, or 0.5. And all of that is being divided by m1 plus m2, so 10 plus 15. So when you punch all of this into a calculator and simplify, this comes out to about 2.9. And we're talking about acceleration, so our units will be meters per second squared. So that will be our final answer on this one. That is what the acceleration of this system will be. So just to recap, we found all of the forces that were acting on the first block and the second block, and then we determined that ultimately the positive force was this force right here, and there were two negative forces, so the force of friction and then this parallel force right here working on the first block. So once we found all of those forces, we simply set them equal to the net force, which we could simplify as m1 plus m2 times A, and then we were able to solve for A.